In this tutorial, we will focus on vector definitions. A vector is a collection of n elements. Here is an example of vector v, where v is a vector of order n. Usually for a vector of 2 or 3 dimensions, we associate the vector with coordinates x, y, or x, y, z. To represent the vector on the graph, here are the examples of 2 dimensions and 3 dimensions. In general, we cannot draw a 4 or above dimensional vector v. But we also can use an arrow to represent v, where O is the origin.
A vector can be represented by arrow, where the length of the arrow is proportional to the length of the vector, and the direction of the arrow and the direction of the vector are the same. Vectors can be written in 2 ways. The first way is place an arrow on the character, or bold the character. The second way is place an arrow on 2 characters, where A is the starting point and B is the end point.
Operation of vector. We are going to add up 2 vectors. Let u and v be 2 vectors of order n. Please note that the order of the vectors must be the same. The sum of u and v is equal to a new vector, where its elements are the sum of corresponding elements of u and v. Here is an example. Graphically, to add up u and v, there are 2 ways. The first way is to translate the vector u, such that the starting point of u is on the end point of v. Then, u plus v will be an arrow with starting point that is same as the starting point of v. The end point of u plus v will be on the end point of u after translation. The second way is to translate the vector v such that the starting point of v is on the end point of u. Then u plus v will be an arrow with starting point that is same as the starting point of u. The end point of u plus v will be on the end point of v after translation. The next is the negative of vectors. Let v be a vector of order n. Minus v is a new vector where its elements are the negative of corresponding elements of v. Here is an example. Graphically, we can find minus v by reversing the vector v and place its starting point on the starting point of v. We are going to find the subtraction of 2 vectors. Let u and v be 2 vectors of order n. Please note that the order of the vectors must be the same. The subtraction of v from u is equal to a new vector, where its elements are the subtraction of corresponding elements of u and v. Here is an example. Graphically, to find u minus v, there are 2 ways. The first way is to reverse the vector v to be minus v, where the starting points of v and minus v are the same, and then translate the vector u, such that the starting point of u is on the end point of minus v. Then u minus v will be an arrow with starting point that is same as the starting point of minus v, and the end point of u minus v will be on the end point of u after translation. The second way is also to reverse the vector v to be minus v first, where the starting points of v and minus v are the same, and then translate the vector minus v, such that the starting point of minus v is on the end point of u. Then u minus v will be an arrow with starting point that is same as the starting point of u, and the end point of u minus v will be on the end point of minus v after translation. The last operation is scalar. Let V be a vector of order n, and k is a constant. K times V is a new vector, where its elements are the k times of corresponding elements of V. Here is an example. Graphically, on the left, the vector V is enlarged 3 times along its direction to be 3 times V, where the starting point does not change. On the right, the vector V is enlarged 2 times along its direction to be 2 times V, where the starting point does not change. Length. Let V be a vector of order n. The length of V, denoted by this symbol, is a positive real number. Here is the formula. Graphically, on the left, 5 is the length of V. We can find the length of vector V by using the formula on the previous page. Hence, the length of V is equal to square root of 3 square plus 4 square, and it is equal to 5. On the right, 3 times the square root of 6 is the length of V. The calculation is on the bottom. Unit vector. Unit vector is a vector of length 1. The unit vector of V is denoted as hat V. We can find unit vector of V by using the formula below. Hat V is equal to V divided by length of V. For example, let V be a vector of order n, with elements v1, v2 to vn. Then the unit vector of V can be found by using the formula. The steps are shown on the bottom. Graphically, the starting points of V and hat V are the same. The directions of them are also the same. The length of unit vector of V is 1. We can find the unit vector of V by using the formula on the previous page. The calculation is shown below. Dot product. Let U and V be 2 vectors of order n. Please note that their orders should be the same. The dot product of U and V can be written by U dot V. There are 2 equivalent ways to find U dot V. The first way is to sum up the product of corresponding elements of U and V. The second way is the length of U times the length of V times cosine theta, where theta is the angle between U and V. Here show that YU dot V is equal to the length of U times the length of V times cosine theta. Cosine formula is used on the first row of the proof. Here are some examples of dot product. If U and V are parallel, the angle between U and V is 0 degree. Then U dot V is equal to the length of U times the length of V, since cosine 0 is 1. If U and V are perpendicular, the angle between them is 90 degrees. Then U dot V is equal to 0, since cosine 90 degrees is 0. Here is an example if the angle between U and V is 30 degree. Note that the angle between V and V is 0 degree. Therefore, V dot V is equal to the square of the length of V. By using the dot product, we can deduce that U over the length of U dot V is the projection of V on the direction of U. The proof is shown below. Here are some properties of dot product. Please note that the order of u, v, and w must be the same. We can also represent the vector by using arrow when the dimension is greater than 3. Exercises. Here are some exercises. Try to do it now, and see how well you understand the topic. This is the end of the tutorial. Thank you.